In our previous lecture, we talked about visiting some of the comets. So Halley's Comet being the very first one visited by a spacecraft, though from quite far away. And then we had Comet Borrelly, we had Comet Viot-2, and several of these comets that were visited here. So we're starting to get ideas of what comets look like. Finally, NASA had an even more ambitious plan, and that was something that they called deep impact. So in July of 2005, the Deep Impact spacecraft was launched. And the idea was it was going to fly. Again, it had armored plating on it, protected from particles slamming into it. So again, Whipple shields on it. It was going to fly into the path of a comet and detach an instrument package that was very rich in copper. The copper is very rare in comets, so when it slammed into the comet, then what would happen is that the explosion, because again, it's going to basically it moves in the path of the comet, and then the comet comes slamming into it, and so it's an impact. I mean, it's not like we're flying into it. This is more like you're driving down the highway and you get a bug splat in the window. It's not like the bug targeted your car and flew right into the window. It's like the car ran into the bug. Okay, and so that's kind of what's happening here. It's going to impact the comet in that fashion and create a crater. The difference in speed was going to be so much to create a crater the size of a football stadium. And it's going to blow all this stuff out, and then the mothership would monitor the stuff blown out to figure out the interior structure of a comet. The original comet they had picked that was going to be coming in, turned out they couldn't find it again when it was coming by, so it either dissipated or was so far off course we missed it, and so they instead picked Comet Tempel 1. Now this is a very short period comet. This is a comet that comes by about every 5.5 years. It's really an asteroid belt comet. So it's not exactly your normal comet. So the impactor was going to create this big explosion when stuff spewing outwards. Mothership would be flying past and do spectral analysis of it. So here's the comet right here, Tempel 1. And as they came in, it's, again, this is a short period comet. This is like an asteroid belt comet. When they looked at it, they got close to it. Again, this is what it looks like from Earth. Get close to it, and it looks different than all the other comets. It's very smooth. We've got parts of it that have craters in it, and we have parts of it that are totally smooth. Other parts here, they're totally smooth. Smooth means it's been resurfaced in some fashion. Well, what does that mean? Well, one possibility is that something from the inside worked its way out, okay, like volcanism. Okay, ice volcanoes. For example, you heat the ice in the middle, it melts or tries to melt and works out on the surface and solidifies. So that's one possibility right there. But that would be something we had not seen in any other comet. And again, you can't see any of this stuff until you get close. So as the impactor was coming in, we got, it was sending back pictures, and again, the smooth floored craters right here indicating that they've been filled in. Okay, smooth regions up here, cratered down here and rough, meaning it's not been altered, and then some of the last views of the impactor right there, right before it slammed into it. And then from the mothership, we saw the big flash, and we could get the spectrum of the flash, fit the spectrum to various elements, figure out what makes it up, and sure enough, it's made up of ice and rock and minerals. Okay, kind of the composition we expected for the most part. Okay, but here's the interesting thing. The crater, 100 meters in diameter, so that's, again, the size of a football stadium, okay, like a high school football stadium, okay, and is about 30 meters deep, okay. So pretty sizable hole we blew into it. But what happened was, it wasn't just that it hit and blew stuff out. It blew stuff out, then more stuff, and then no more stuff, then more stuff. The stuff that came out didn't just come out all at once. It went poof, 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 poof in several different sorts of events. And then what they found was that each little piece that came out, each cloud that came out, was different stuff, indicating that this object is layered like an onion. That was totally unexpected. They expected it would be dusty and rocky on the outside, and on the inside to be pretty much as expected. Just rocky ice mixture. So it'd be pretty uniform on the inside. That's not exactly what they found. Outgassing continued for 2 more weeks, peaking about 5 days after impact, more stuff spewing out. What was a little surprising was way more dust and way less ice was spewed out than we expected. We expected the comet to be much, much icier than it was. Okay. Some of the minerals that were found coming out required liquid water to form. Not just water, but not just the presence of ice, but liquid water to have a chemical reaction in there. And so that was a completely new finding. They didn't expect that at all. And so that was a big shock right there. It was very low density. This object was more like a snowbank than it was an iceberg. Almost 75% empty space. So this was a huge surprise. Now, what does this mean? This object, remember, is like an asteroid belt comet. It's been trapped. It may have come from the outer solar system, but it got trapped by the gravity of the planets here to be in this orbit that comes back every 5.5 years. In that time, that means it is spending a whole lot more time in the inner solar system than other comets. That would maybe explain why there's far less ice. That stuff, the ice may have already been mostly sublimated, so we have much less ice than we expected. That would leave behind the dust. The other thing here that was a little odd was the liquid water component here. We did not see liquid water, but we saw minerals that needed liquid water, suggesting that maybe it being close to the sun, it heated up enough that on the inside the water melted somewhat. Now, this is actually a huge discovery because liquid water is one of these things that's really important for life. And so we have liquid water mixed with organic molecules. Now, it probably didn't stay liquid long enough for life to develop or do anything. But again, this was a huge discovery suggesting that comets play a much bigger role in the solar system than we originally had suspected. Now, the interesting thing here is none of the comets that we saw looked like any of the other comets that we saw. So this once again suggests that comets are just as rich of worlds as planets in terms of the diversity of the kinds of objects they are. Remember, we think that the origin of the comets, there's multiple ways you get comets. They form in the propylid. They could have formed midway in the propylid, farther out in the propylid. They could have been moved around by the planets moving them around. So there's a lot of stuff that goes into forming these things, indicating that they're not all just alike, which is what we're finding. Originally, the spacecraft was going to continue flying past Comet Boethian, but Boethian was completely lost, and they flew by instead a more recently discovered Comet Hartley 2, and it flew by in November. And the idea is towards the end of 2020, it's about to fly by an asteroid, assuming that budget didn't cut in the last couple months of the year. So here is a graphic showing some of these asteroids and some of the comets here side by side to give an idea of about the size of these things. And notice that what we find are some of these comets that we see here are in the ballpark of some of these asteroids that we've seen. Not the bigger asteroids, but some of the smaller asteroids that we've seen. And so that gives you an idea of where comets fit in here. And again, most likely comets form as icy sort of objects analogous to asteroids forming. There is evidence that with this mixture of the solar system, you know, some of the hot stuff moving out, cold stuff moving in, the asteroids probably have more water in them than we thought they did, and the comets probably have more rock in them than we thought we did. At one point, we thought about the asteroids as being just rocks, and the comets as just ice. Now we're thinking of, well, the asteroids are more rock than ice, and the comets are more ice than rock, but the exact percentage is variable.